after which I'm gonna, good. We are live. So this is the Dutch Clojure meetup number 128. This time around, I actually look back at the history and I'm sure it's meetup number 128. And that means 128 consecutive months of Clojure meetups in the Netherlands, which is, I guess, something. At least it's something for me to go very proud of. And it's actually super crazy times right now. It's super hot in the Netherlands, so something maybe hell is freezing over at the moment. And we are online once again because of, well, it all started with Corona, and I have to say I'm starting to like the online meetings, although I miss you guys quite a lot. And another, let's say, non-usual thing is that we do have an agenda. We have actually somebody that's going to present something awesome to us. And I think I'm just going to leave the stage to the speaker because he can probably explain better about himself and the project he's going to show us. So yeah, Kevin, floor is yours.
All right. I'll just share my screen then. Let's see. Put up my slides. Right. So this slide should be viewable right now. Can somebody confirm?
Yep.
Yes. All good.
Okay. Great. So today I'm going to be talking about Gugnir. This is a data-driven database mapper for Clojure. It's a personal project of mine, and basically it is an all-in-one tool for managing the database within Clojure. So a little bit about me. My name is Kevin. I work full-time as a Clojure developer at MediQuest in the Netherlands. I generally spend 50-50 on Clojure and Clojure scripts with some front-end development. Guess a bit of a full-stack developer in that sense. This project is a personal project of mine, so it's not related to MediQuest as a company. We don't use it at MediQuest at the moment. So this is purely a personal project at the moment. I worked on Erlang, Elm, and Elixir at previous jobs, and this project is also influenced by the Elixir Ecto library, something that I missed in Clojure and was one of the reasons why I built this. So what is Gugnir? It's a data-driven database library where it helps you map Clojure maps to SQL tables. So for example, in Clojure, you might want namespace keywords, which are kebab cased, where the namespace might be the table name and the name would be the name of the column of the SQL table. And SQL table columns are snake cased. So it handles that kind of mapping for you. Also handles data validation and transformation. So you could think of things like where when you save a user to the database, you want to make sure that the email is the proper format. You might want to make sure that a password is at least a certain amount of characters long. It also does transformations in the sense that if you save a user to the database, you might want to lowercase the email, because if you want to search an user by email, then that would make it a lot easier because you could just lowercase the email when you do a find by statement. It also provides reading and writing to the database in a with a protocol, and it makes use of existing libraries. So it's not a completely new thing. Not everything is made from scratch. So it uses Molly for validation, which is basically a data-driven spec, simply put. It uses HoneySQL for querying, which is a data-driven SQL language for Clojure. And it uses NextJDBC for actually connecting to the database and doing some transformations after querying. So a couple of goals for this project is that I wanted to have a data-driven solution for communicating with the database, an all-in-one data-driven solution, I should say. One of the things that I really like about data-driven is just it's very clear, and I think Clojure is the first language that really introduced me to this concept. And I really, really enjoy that. So that's one of the goals that I wanted to achieve. So no macros. Fast project development startup time. So when I start a new project for myself, a personal project, I really want to get started very fast on the product that I'm building. So whenever I start a new product, you have to do all these tiny things. It's just, I just want to try and mitigate that as much as possible. And a standardized validation and transformation scheme, so that you have a bit of a guideline on how you want to handle these problems. So data-driven, as I said, I really like the data-driven architecture. I've been working a lot with libraries such as Molly, Integrant, Hiccup, Honey SQL. These are all libraries that I really enjoy, and I always use them. I tend to shy away from libraries that are more macro-driven. So whenever I see a def something in the API of a library, then I immediately just get the urge to not want to use it, even though it might be a really good library. The initial thought I get is that I don't want to use it. In the end, I still might use it. So, for example, I still use Clojure spec, even though it's mainly macro-driven. But if possible, I like to have it data-driven. So fast project development startup time. Whenever I start a new project, I have to set up Hikari CP, Next.jdbc, ragtime. You have to do the mapping. So for example, you have to make sure that the kebab case gets converted to snake case and vice versa. And there's all these little things that aren't really difficult problems, but they're not really problems that I want to be solving, because I'm not. These are not the things that I'm aiming to solve. I just want to build a product, and I just don't care about these things. I would rather just have these things be done for me and not have to think about them. So the goal of this is just to have an instant setup that I can just use and just get going with building a product. Standardized data transformation and validation. This is also a very big one for me, because you have a lot of situations where you need, well, in a real world app, you need to validate everything that you're saving to the database pretty much. And you also need to transform things. So for example, you need to check if a password is strong enough. You might need to check with a password confirmation if the password is actually matching another input field that the user has presented. You need to encrypt the password before you save it. And these are all things that it might sound like a single use case initially, but you might have a registration form. So you would register a user with a email and password, save it to the database, make sure that the password is encrypted. But you might also have a update passwords functionality in your profile page. So then you would have to check all these passwords validations again and transformations for encryption. And you might also have a email reset passwords functionality. So it would send an email for a link where you can update your password again. So now you're using the same functionality in 3 different places. And you might solve the problem ad hoc, or you might think of your own structure to manage this, but it is a problem. And I just like to have something to unify these problems, and that you just define these rules once and it'll just work. Mapping Clojure maps SQL rows. Well, basically I just want to write Clojure and I want to make sure that it gets saved to SQL properly. And when I read from the database, I just want to get Clojure maps instead of something else. And that's really all that's to this, to be honest. So is this an anti-Clojure solution? Because generally speaking, what I hear Clojurians say a lot is that they tend to, for a new project, they tend to choose which libraries they want and put it all together and create their own architecture. And I understand this because you would want to use the tool for the job. But for my use case, generally speaking, this is okay if you're working for a company and you're granted the time to build your own architecture. But if I'm working on personal projects in my free time, I need to make the most out of the free time that I get. So I don't want to be spending time for each project making the best architecture I can think of. I just want to get the product out there as fast as possible, because sadly, most of my projects won't succeed. They will probably just die off and get thrown away. So if I spend all this time picking the perfect libraries and setting up the best architecture, it's just going to be a waste of time, because the project isn't going to succeed anyway. At least I hope it will, but chances are very low. So this is more of a library to get you up and running as fast as possible, which makes it also a very interesting choice for beginners, because when you start for the first time as a Clojurian, you have to figure out how everything fits together. So you have JDBC, you have a migration library, querying library, and all these other things. And halfway through the process, you're almost there, and then all of a sudden you realize you actually should be using Next JDBC for certain features. And that happened to me, and I know other people that also experienced this. So I try to provide same defaults, which could help new users as well to getting started faster, and then eventually migrate to their own solutions or something like that. One of the features that Gugnir provides is models. This is derived from the Elixir Ecto library. Basically, what models do is they describe your Clojure map, and this Clojure map is then related to the table in SQL. Now, models are written with Molly definitions, and as I said, Molly is a data-driven spec, simply put. And it allows you to define a Clojure map, say what types of fields it has. You can add properties to these fields as some kind of metadata. So you can add extra context to these fields, something that spec doesn't support as far as I know. And it adds a lot of really interesting functionality, such as error messages and data transformations. It's very, very cool. But that's basically used for models. So as said, it describes your Clojure maps, what they look like, the types of the fields. It adds before save, before read, and after read hooks. So for example, you might, before you save a password, you would want to encrypt it. So you would have a before save hook to actually do that. You might also want to underscore emails. So you can add a before save hook for that. And if you read from the database using an email, so you would find a user by email, you could add a before read hook that would actually lowercase the email before you read from the database. And so if you do this, then you can always read by email without having to worry about case sensitivity. It also allows you to define relations between tables. And this way you could also create loose joins, which I'll show later in the presentation. Next are change sets. Change sets are the actual how you use the model. So you have the model as a definition, and change sets is really how you apply it. So you use to validate data structures before saving it. If a password is not strong enough, or an email doesn't fit the regular expression of an email, anything like that, or if the password doesn't match, then you can actually return a error to represent that. You can also customize these errors to make it more readable for the end user. You can also add, you can also return a diff of the changes that you're about to save or update. So if you have a new user, you would see that all the fields are new. If you would update the password of the user, you would see that the password field has changed, and you can actually see the differences in these things. Next, you can cast foreign data to actual Clojure maps. So, for example, you might get JSON data from your API, and you would want to convert that into a Clojure map. And then these change sets can also help you achieve that. And then it would map to your model structure. Then we also have querying. So by default, it uses HoneySQL to actually provide queries. HoneySQL is a data-driven query language for Clojure, and it allows you to build up queries of data and generate a SQL query out of that. It allows you to save change sets. So change sets are really is the bridge between Clojure and the database in terms of saving to the database. And once a change set passes all its validation tests, you can use the querying namespace to actually save these changes. Then you have a relational atom, and this is a special atom that if you query a user, for example, and a user might have multiple posts, your users will also have a relational atom related to the posts table. What happens then is if you deref this atom, then it'll actually execute a new query, and it will get all the posts of that user. You can also swap this atom to change the behavior of the query. So you might limit it to the top 5 posts, and you can add that with HoneySQL. Then once you deref it, you actually get the result of that. So here I'll show a demo. You should see my Emacs by now, if someone can confirm.
Yep.
Great. All right. So this is the Gugnir playground. This is a public repo on my GitHub. It basically shows off any or all the features of Gugnir, or almost all of them. So we can just step through this. In order to connect to Gugnir, you have to create a data source, and the data source accepts one of a few things. It accepts a database URL. So this might be, this is a very standard URL type that is used by services such as Heroku and Render. You have JDBC database URL, just standard. And it also accepts a Hikari CP configuration map. So here we have a configuration map where we just connect to a certain database. And with this make data source function, you can actually connect to this. And so once that is connected, there is a database dynamic variable that is connected to this, or that has this data source. And generally speaking, you won't need this afterwards, because the API that Gugnir provides will manage this for you, but it's there if you need it. By the way, is this readable? I'm not sure if it's too small.
I think it's readable enough, yes.
Okay, I can maybe do one more. Okay, so in this example, we're going to create a few tables. The first thing we're going to use ragtime for the migrations. Currently, Gugnir doesn't have its own migration solution. So the suggested solution for now is to use ragtime. So here we add the plugin to support UUIDs. We have a trigger to update the updated @, column for any table. Here we have a user table with a ID, which is a UUID, an email, passwords, created @ and updated @. Then here we have a post table with a ID, title, contents, and a reference to a user ID. And we have a comment which has content and a reference to a user ID and a post ID.
Kevin.
Yes.
Is there a reason you're using quotes around the table name?
The reason that I'm using quotes is because the user table will not work if you don't use quotes. So if you're going to use the user table, then you need to actually quote it. But yeah, because well, this is in the case of Postgres, because Postgres has its own internal user table for the actual Postgres users, and if you use double quotes, then you can actually create a user table like normal.
Isn't that why in Postgres we would do schema.table, so public.users?
I'm not quite sure about that. It could be true, but
At least
not
that's my experience with Rails. You usually do schema.table name for create. That way you don't really need the quotes unless you have a conflicting like namespace or anything.
Okay, I'll be looking into that, because that would be nice to have a proper solution for that, to be honest. Yeah, it's really annoying that you can't just use user, but sure.
Yeah, I know.
So,
and it makes copy and pasting out of your database tool much easier if you can just copy paste it without doing all these quote unquote transformations to make it run in your database tool or in your Hiccup.
Yeah. Okay. So now we just run the migrations, and this creates the tables and the plugin. So this is a public repo. So if you are interested afterwards, you can clone this and you can walk through this whole process yourself and just play around with it. So this is a Molly map, and we're basically defining a map structure using data, where we say the user ID is a UUID. We have the user email, which is a regular expression that is a very simplified email regular expression. You would probably want something more advanced than this, but it's just an example. You have the user password, which is a string of minimum 6 characters. And we have a user created at and updated at, with which is an instance. Now, Molly also provides properties for keys. And basically what these properties do is it allows you to add, quote unquote, metadata. And the end user can really decide what to do with this data and decide what it means. So for example, we have here primary key true, which tells Gugnir that the user ID is the primary key of the user table. That's really all this does. And Gugnir knows how to actually handle it. There are also built-in Molly properties. So for example, error message with an invalid email string. This is internal to Molly itself. And if this regular expression would fail during validation, it will actually show this message instead of the standard message. So that adds extra readability for your end user. Then for created at and updated at, we also have an auto true. And basically what this does, it tells Gugnir that this is a column in the database, but do not attempt to update it or simply write to it, because our created at and updated at fill themselves in. So updated at gets adjusted every time you save to the database through Postgres, and created at is set during creation. So this just tells Gungnir that it shouldn't actually do anything with this. Then we have the Gugnir model register function, which takes a map, and the key is the model name, in this case user, and the map itself, or the data itself, that's the actual model. And then once you register it, it registers the user model into a public registry that can be used later. Next is change sets. So now that we've created a user model, we can actually use change sets with that. So for example, here we have a map with a user email and user password. Gugnir knows that this is regarding the user model because we're using namespace keywords. So this is the namespace user. So Gugnir knows, okay, we're talking about the user model. So we don't actually need to specify that as well, which I think is a pretty cool feature. If we evaluate this, if you look down here, we see user password should at least be 6 characters. So here we have 5 characters, And if we create a change set, we see that that it actually has errors because the password isn't strong enough in this case. Now, if we were to actually provide a proper password, then you can see that errors is nil. So this basically means that the change set passes all its validations and it's ready to be saved. So there are a couple of other fields in a change set. I think you can see that here. Well, basically it has a origin and a transformed origin. And this is the original data structure that you're actually transforming. In this case, we're creating a new user, so there is no origin. And then it has a params, which is what we're trying to modify the user with or create a new user with. And then we have a result key, which actually tells us this is the resulting map of a user that we're going to be inserting into a database. Then there's also a diff, which tells us which fields have changed. In this case, all fields have changed because it's a new user. But for an existing user, if you were only updating an email or password, then only that key will be shown in the diff, which could come in handy for certain situations if you only want to update a specific key. You can also cast data with change sets. So for example, here we might have or JSON data that came in and it's not namespaced. So we actually need to cast that to a user model map. So here we just use the cast function with a user keyword. And then if you look below, then you see that the user email and password is actually set into a proper map now. So now it's ready to be used as a change set. You can also sanitize these maps because, for example, here you have an email and a password and an unknown key 123. Well, this key is not known in the model. So if you actually evaluate this, then this key will be discarded. So any unknown data that is received from the API, once you cast it, will be discarded if it's not part of your model. So that adds that extra safety in that sense. Once you create a change set, you can actually use the querying namespace to save a change set. If you're creating a new user, it will just be created. If you're updating a user, it will be updated. And the save function actually knows through the change set which action to apply. Now, in this case, the password is incorrect. So if we were to actually evaluate this, then if you look bottom, then you'll see again the user password should at least be 6 characters. So if you try to save an invalid change set, it'll simply return the change set without applying any side effects. So you can't accidentally save an invalid change set. Now, in the case that you actually do have a valid change set, so for example here errors is nil, you try to save this, you actually create a new user and the save function actually returns the created user that has been inserted in the database, including the new fields as well. So for example here you have the ID, which is a UUID, you have the created at and updated at, and these are things that weren't part of the change set that you provided, but these are things that are handled by the database itself. So that also gets returned, which can come in handy if you want to, for example, redirect to a user that's been created and the UUID or something is needed for that. Next up is querying. So there are a couple of functions that Gugnir provides to actually query users. There are 3 main functions. One is the find function, where you provide a model name and a primary key. So in this case, it's a UUID. If we actually run this, then you see that we get a single record back, which is the record that we inserted previously. So find basically finds a single record from the database. If this record doesn't exist, then you get nil, so it doesn't return anything. Next, we have find by, and this is a function that finds a single record by key value pairs. So for example, here you have a user email and then a user or a email. Once you execute this, it actually finds that user that has this specific email. And again, if this email doesn't exist, then you get nil. Then lastly, we have the all function, which also accepts key value pairs. And the only difference of defined by is that this returns a collection of records instead of a single record. So here, since we only have one user, you will only see one, but you can see that this is in a vector instead of the map itself. So these are the three main functions that you will be using to query the database using Gugnir. So next, we're going to create 3 users. And something that's pretty cool, I think, about these functions is that they're simply extendable with HoneySQL. So for example, here we say with HoneySQL, order by user email descending, and we say limit to. Then as a result, then we get 2 users. We'll probably return this. And you can see that we have the user 3 and user 2. So this is sorted on email descending, and we only get 2 users, even though we inserted 3. So these Gugnir functions are extremely extendable using basic HoneySQL. So it's not reinventing the wheel in that sense. So you can fall back to pure HoneySQL if you want, which I think is a really nice thing. So it doesn't limit you if you just want to do HoneySQL in that sense. Next are validators. So here we have our user model again, but the one thing that we added is the password confirmation field. Now this is not a field that we have in our database. This is not a column in our database, in our user table. So what we can do is add the virtual key true as a property to this key. And what this means is that this key is part of our user model, but it is not part of our database schema. So Gugnir will accept this as a model key, but it will not attempt to query or insert it into the database. And this is very helpful because now we can use this key to validate if the password and the password confirmation are actually matching each other when you try to save a user or update a password. So here we're going to create a simple function, password match. You just check the password and password confirmation key from a map. Very simple. Then we create a model validator, give it a key. We will call this user password match. A validator is a map of 3 keys, which one is a key that says which model key is or about which key is this about. So here we have the password confirmation key, and here we say it's about this key. So if there's an error regarding this validator, then this will be the key in question. Next, we add a fn, which is just a plain function, which is the function password match that we created earlier, and a validator message in case this validator actually fails. So passwords don't match will be displayed in case this function returns false. So next, we have a user record. This is a new record, so it's a new user that's going to be inserted with a valid email and a valid password, but the password confirmation does not match the password above. Then we create a change set, but the difference here is that we add an extra vector with validators. And in this case, we have the user password match validator. And if we actually run this, then we get the error that the passwords don't match. So if we were to actually remove this validator, then there won't be any error because the email and password match each other. Now, there are a couple of reasons why you want to have this as a separate validator and not in your model itself. Is one, password confirmation is very situational. You would only want to do this if you register a user or update their password in any way. And money models don't have they don't know, the keys don't know about each other. So if we look back here, the user password does not know that user password confirmation exists. So you can't have this kind of rule inside of a map in Mully unless you go outside of the map and add something like this, where you can add an extra validation here that the map has to, this has to be valid, but then also the passwords have to match. So instead, you can just add a custom validator and use it whenever you need it. So that's basically the main purpose of extra validators. So it's for situational things and maybe relations between keys. Next are hooks. So like I said before in my talk, you could, if you want to save a user to the database, you might want to lowercase their email address. So here we add two hooks, a before save and before read hook with the key string lowercase. Here we this is a, okay, so this is a valid, or a hook that is defined within Gugnir. So you don't have to define it yourself, but you can also define your own hooks if you want. But basically what this does is before you save a change set, it would lowercase the user email if it exists. And before you read from the database using a HoneySQL query, it will actually lowercase the email that you're matching with. So for example, here we have a user email with someusermail.com with a lot of weird capitals, and a password. We create a change set and we save it. So now we have this user saved in database. And now we do use the find by user email. And here we have a some user mail which has a different, which has different capitals. So wait, I didn't evaluate this. Okay. Okay, now I kind of messed this up, I'm afraid. Okay. So now, even though the capitalization is different, it's still able to find this user by his email, because before you save the email and before you query it, it will always lowercase the email. So this is very handy if you have a login by email page where the user can log in using their email, but you don't have to think about case sensitivity anymore, because you have defined it in your model, which is a unified place where this will be valid for anything. And so if you search a user by email, then this will just work, which I think is a very nice thing, because I know that I had to just use the string lowercase function on every input that I got from users. And even though it's not a big deal it's not a lot of code to do that, but it is very error prone, because you might just forget it somewhere, or it can still clean up a lot of code, I think. Right, and next you can also add. So here you have a custom hook. So here we have a before save bcrypt hook for your password, and here you actually define it. So you just say model before save, and you define it with the bcrypt key, and all you're doing is you're using the buddy hasher's derive function on the value. So now if you would save this user, look at the password, you can see that the password is now encrypted. So whenever you create a user, update their password through the profile page with an email password reset functionality, the password will always be encrypted no matter what. So you don't have to think about that anymore, because it's defined in your model. And another thing is, if you would update the email address, then it wouldn't apply the before save hook on the password again, because the change set is actually diffing which fields changed. And since the password field didn't change, it doesn't actually need to update it. So the change that's actually smart in that sense that it doesn't accidentally apply the same before save hooks multiple times if it doesn't change. So that's really nice, I think. Then relations. So the last part, I think. You can define relations. This is more of an extra thing. This is not really one of the main features of Gugnir, I think, but I thought it was a interesting idea to really think about. So in the user model, we can add properties to the map itself. So this is not a property to the key, but to the map as a whole. And we can say, well, this user model has many posts through the user post key, and it has many comments through the user comments key. So that's the only change that we made here. Then we create a post model. So here we say belongs to user through the post user ID, and it has many comments through the post comments key. So I'll define that as well. Well, same for the model comments. It belongs to both the user and post model. Next here we have the Gugnir register, and we can just register these models like this. So we just defined them in a separate def and then added it to the map here. So we can just register that. Then we have create user, create comment, and create post function. There's nothing special. And then this is just a function to create a user with a bunch of posts and comments. So that's all that really is. So now we have a user with a bunch of posts and comments. And what we can do now is we can say find by user email, user posts at mail.com. Then we select the user post key from this user, and then we deref that key. And what that will result in is, this is a bunch of data, but it's all the posts related to this user. So if you remove the deref, then you see that this actually returns a relation atom, which is a special atom that once you deref it, it'll actually execute a query. So Gugnir creates this atom with a predefined query that allows you to query relations at a later time. So it's a delayed query, actually. So even though you're just finding a user by their email, doesn't mean you're actually getting all their posts immediately. If you want, you can also get their posts through derefing the user post key or the value in that key. What's also pretty cool is that these atoms can be adjusted using swap. So you can use swap to apply HoneySQL functions and modify the result. So if we do the same, we find a user by email, get the posts, we swap that atom with a limit 2, deref that, and then count, then we get a result of 2. So if we were to change this to 3, then you actually get 3 results. So the reason that I'm counting this instead of doing this is you don't really see how many results these are. So that's the main reason. So this is, I think, really interesting, or an interesting idea to think about, is using atoms to delay queries in this sense. I think it's a very interesting idea, but it's not really complete. I think there's still some issues with this, I think. Then next, we can also use the load function. And this is the same as selecting the key and derefing it, except that the user, you don't lose the user record. So you deref it inside of the user model. So this is a bit unclear, but in this comment, you can see that it doesn't return all the posts. It returns the user with all their data. And the post key gets updated with all the posts inside of that. And it also has a comments relational atom that isn't derefed. So you haven't applied the query yet to get all the comments for this. You can also load multiple relational atoms at once. So you can load the user posts and comments at the same time. And then in this comment, you can see that you actually get both comments and posts in the user record loaded. Yeah, so these atoms go two ways. So for example, here we're getting the user by email, getting the posts, dereffing that to get all those posts, then use the first function, get the first one. Then with this post, it also has a post user key, which is also a relation atom, which relates to the original user that we called here. It's the user that is the owner of this post. Then if we deref this, what happens is we actually get this user record back again, because we're actually made a full loop querying these. This is, of course, not something that you would actually do, but it's just to showcase that it's bidirectional. You can go both ways. And so here you can just also chain it. So for example, here you would find a user, get all their posts, then get the first post of that user, and then get that post's comments. So here you would get all the comments of this user's first post. So that's a way to chain these types of atoms. And since it's goes both ways, you can just keep going if you would want to. So what's next? I still want to create some kind of migration library, and I don't want to create anything too advanced. I would probably use ragtime to do the heavy lifting for me, but I would still like to define a lot of things using data instead of having to write raw SQL. I think that would be nice, and it would probably be a bit simplified with a fallback to raw SQL if you really need it. Another thing is to make Gugnir more modular. Someone approached me and said that they really liked the idea of change sets and models of Gugnir, but they use HugSQL instead of HoneySQL. So that's a bit of a problem because HoneySQL is really integrated into Gugnir at the moment. And so what I'm thinking is it would be interesting to have the model and change set namespaces that is really the core of Gugnir. And then you can add HoneySQL and Hikari CP as modules to complete the entire stack. And so if you want, you can create a module for HugSQL as well that you can actually just add HugSQL instead of HoneySQL. I do want to still make HoneySQL and Hikari CP the defaults because I still want to retain that plug and play feel with this, but you could still exclude HoneySQL if you want and then add HugSQL instead. But that's something still for on the roadmap. And another thing is about the relational atoms is preloading. So I think it's interesting that you can delay querying relational atoms, but a lot of times you would want to actually do it all in one query because it's not because it's just more efficient to have a join instead of a separate query to get relations. And so a relation atom preloading feature would be nice to actually build up the query before you get the initial records, and then it would just create a join to create any relational data that you're interested in, just to improve performance. So if you'd like to learn more, there are a couple of ways to do that. So you have the Gugnir GitHub page, and just explains a bit what it is. Then there's a guide, which just explains all the features and what you can do with it, and just in detail how all these things work. So that's quite a bit of documentation there. So there's more than enough. And there's also the Gugnir playground, which I just showed you. And it's just allows you to walk through everything that we just covered. And you can just play around with it and try whatever. And there's also a little example here how you can use this in the UI. So there's another UI module for Gugnir, where here, for example, I'll just zoom this in a little bit. We create a user map that we've already seen with a password match validator. So this is what I already showed you before. Then in Clojure script, you can create a form where you add a data Gugnir form and with a register key. And you add labels with a Gugnir error class related to a certain field. So these are the only two things you really add to your form. So you can just use existing forms. Then next you create a handle validation multi-method with a register key. And all you're doing is you get the params from the form, you cast it to a user, and then you create a change set from this. Then in your Clojure script, you can init this module. And then out of the box, you just get this validation for free in your front end. Since Gugnir is written mostly in Clojure C, so the change set and model part is written in Clojure C, it can also be used in Clojure script. And so this extra module allows you to have form validations using the same model and change sets that you use in the backend. So you only have to write these validations once, and it'll work for both the front end and the backend, which I think is also a pretty cool benefit. And that concludes the presentation. So are there any questions?
Yeah, I do have one question.
Yeah.
Thanks for your presentation, by the way. It was inspiring. So why do you choose nested or a data structure with all kinds of atoms in it and don't work with just plain data? And similar question is, why do you choose atoms and not delays or something? So could you tell a little bit?
Yeah. So initially the idea for the atoms, it's still a work in progress. So I don't know, maybe there's a much better solution, of course. One alternative would be to just use HoneySQL. So you could actually just have a HoneySQL query in that field instead. But futures, I'm not sure, because the whole point is that you can actually swap these atoms and then change the behavior of these atoms before you actually deref them.
Okay, yeah. So you want something stateful. So
yeah.
But you could maybe also just use pure data and then have an explicit function that executes that data or something.
Yeah, that's also definitely a good option. I thought it just was an interesting idea to solve this, but Gugnir is still alpha, so everything is still subject to change. So I'm all open for feedback.
And what is the name? What does the name mean, or where does the name come from?
So Gungnir is is the spear of the god Odin, and so the legend says that that regardless of the wielder's skill, Gugnir will always hit its target. So kind of the joke is that that as a developer, I'm not really a database admin, but I can still work with the database because I'm using Gugnir.
Right.
I don't need a database admin to help me out, basically. But it's kind of a joke because database admins are very specialized in performance and everything, so it's really just more of a joke in that sense.
Cool.
We had actually a few questions also from the chat during your talk.
I can stop presenting now, I think.
Yeah. So yeah, what is like code style? Why do you have main methods with exclamation mark in the name? Yeah. So the before hooks, are they transactional? So if you save a change set, you're actually just saving a single record at the moment. I still need to think of a way to save multiple things, but the hooks are all in context of a single record that you're either inserting or updating. So in that sense, all the hooks are applied, and then the save is executed. So there isn't really a transaction in the sense of multiple queries. It's just a single query that's being executed. If that answers. I guess the question would be, if my after hook fails, does it invalidate the rolls back the transaction or not?
No, but there's
Yes.
no after save hook. There's only an after read hook.
Okay.
So
In terms
I'm
of
not sure
rollback, for example.
Excuse me?
If you need a rollback to the entire transaction, the hooks can do it for you.
Well, right now, I still need to look at how we can do transaction. I think it's one of the issues that I have open right now. So doing transactions and how we want to handle it.
I got the save operation, but I trigger the after operation, for example. And
yeah, but the after operate there are no after save operations. There's only an after read operation. So that if you would read a record, that you would actually do. So for example, you might encrypt a lot of your columns, for example, with a before save hook, and then with an after read hook, you would decrypt those columns. That's an example of how you could use that.
I got it.
For extra privacy or security or something.
Sure.
Let's see.
Good.
Okay. Then let's see.
Why do you use exclamation mark? All methods are advanced, just methods.
That was already kind of partially answered, but
yeah. So it's for side effect.
Yeah. And is there any sort of a glue library inside of Gugnir, like integrant or component or whatever?
No, there is no. You can use anything really. You can use integrant or component or mount to set it up. You would generally use that to set up the data source and probably to create all the models at the start of your application. That's probably where you would actually use this, where you would use something like integrant. But it's really up to you, and you just execute functions, so it's really easy to integrate.
Yeah, thanks. Was it already used by any project that you know of?
There was a company that what I mentioned before that wanted to use it, but they were using HugSQL instead of HoneySQL. And this project is still very new. I think I released it like a month ago or something. So it's still very, very new in that sense. And as I said, at MediQuest, where I work, we don't use this at the moment.
I do also have another question, which is, well, it's hard to formulate in my brain, I guess. So one of the things that I noticed is that your models, they are pretty much creating a namespace for your keys. But what if in so what I'm doing right now in my company, for instance, is to create what we call the data Bible, which is a collection of specs that describe our business as a whole. And many of what I would call entities end up having the same or sharing, let's say, some inner keys, which would have different namespaces. And if I were to adopt Gugnir, then what I would have to do would be to create, let's say, aliases for those keywords, so that within a given entity, all of the keywords share the same namespace. So maybe my question would be, where do you see this tool being the perfect fit, or what kind of flexibility that might be required would end up, making Gugnir not the right choice? Do you think?
So I think you're saying that the way it's modeled right now with registering models is that you're going to have clashes with keywords, or?
It forces me to have all of the keywords for the same model having the same namespace, and in my model right now it's not the case because of the way specification was created.
Okay, so I think I really built this tool really with the mindset of a person that's trying to build a startup or their own application, their own newly made application, where they need to get started really fast, and they don't really care too much about flexibility in that sense. So that's why I'm also saying that a lot of Clojurians, they'd like to pick and choose the libraries that they need and then put together their own architecture. That's definitely not what Gugnir is, because Gugnir does that part for you already, and it helps you with all these little tasks like mapping and validation and all these little small things that I personally wouldn't really want to be thinking about when building a product. To me, it's really about getting something up and running as fast as possible. So if you're really looking for flexibility, which it sounds like to me in your case, then this would probably not be the proper tool for you.
Yeah, that's clear. Yeah, thanks.
And Kevin, it's a goal to be how can I say, as faster as Ecto. Will you follow its design to follow the Gungnir features, or are you going to fork in some way from the version?
So I think the question is, I think that am I going to really copy Ecto or do something a bit more different?
No, but follow the same design. Yeah.
No, because right now there are quite a few differences, I think. So, for example, the way Ecto validates certain things is that they create a model, and they create tiny validators that pick and choose specific keys that they want to validate for specific situations. Whereas I say, well, this is the model for your table, and then you have extra validators that you can add to check things like password confirmation or something. So it's kind of more of a separate process in that sense. But there are certain things that are similar. So, for example, the relational delayed querying. So here I'm using Atoms, but they have their own solution for that. But that is very similar in that sense. And things like chain sets and models, I think they're very similar to Ecto as well. But I'm more going to look at what is more beneficial for Clojure. That's also why I have a more data-driven approach with Honeysequel and the querying around that. Whereas with Ecto, it's more macro-driven, it seems. So I think that's also a very big difference. And I absolutely do not want to see macros in this library. So
we have a question from the chat. Why do you dislike macros?
Well, I think macros have their place. For example, you might get some good performance benefits. And for example, in Clojure scripts, you need macros to read files and things like that. But the problem that I mostly have with macros is it makes things very unclear for me. I can't really see what's going on under the hood. Whereas with Honeysequel, for example, you can just evaluate the expression. You can see all the data that's being executed. And you have a lot of things also with core async, for example. When you get an error, if you have a very complex core async setup and you get an error somewhere, that they can really be a pain to track that down. And I just really want to avoid that. And you also have things like Clojure Spec, which is a great library. But I really like Molly a lot more because it's just much more flexible. You can, for example, something that we're doing with AdMediQuest is we're actually we have this separate configuration which also has Molly in it, and we're sending it over the wire, which is something you can't really do with spec because it's macro driven, or at least it would be very difficult to do. I guess you might be able to pull it off, but it's probably very difficult. But I guess the short answer is it's more flexible, and to me, it's more clear. I guess that's the short answer.
Yeah, sorry, go ahead.
No. By the way, great project, Kevin. I will follow. And I use Daytonic in my current job, and would like to use at least the adapted part of Gugnir. Do you think that it's separable? I can use it independently of the other parts. I only want to use the change set and the adapter functions of the Gugnir.
I guess, yeah, so one of the things I want to do is I want to separate the Honey SQL and Hickory CP out of Gungnir and make that separate repos, and then you can just plug and play. And then you could just take the change set codes and use that. I don't think Gugnir is really at the state right now where you can easily do that,
Yeah.
but it is a goal of mine to make it more. So right now it's very Postgres dependent and Honey SQL and Hickory CP dependent, but I do want to take that more apart, that you can really use whatever you need. So I think right now it's not very feasible, but it is a goal for in the future, definitely.
Thank you, Kevin. Sorry, Carol.
That's fine. That was a much more relevant question. My comment, I just wanted to comment on the macro thing. To me, that I would agree that the main issues that it may make things unclear, in the sense they break the rule in a way. You need macros when you want to alter the order with which things happen or things are evaluated, and macros break that rule because, well, that's what they are for, in order to be able to decide whether or not to execute a piece of code. Even if you've already written it down, you need to use a macro. But then with functions, the order of evaluation is clear and more predictable, and you can follow pretty much whatever you need to do. I think on the topic of exchanging spec-like things over the wire, I think maybe out of the Metozin folks, you might still have something with the spec tools. You do have some sort of an ident representation of your specs, and even in the spec registry out of Clojure spec itself, if you evaluate that as a function, I believe it returns the full collection of specs which are registered in an ident fashion. So it is possible, but I would agree it's not meant to be used like that.
Okay, that's interesting. I didn't know about that.
Yeah, it can be surprising, because if you see all of the specs that are registered in your runtime, then you see all of the specs coming from third-party libraries and stuff like that. So suddenly things start to pop up all over the place.
Okay, yeah. Cool.
Do we have any more questions? I guess maybe that's no. Maybe that's a no. Okay, so Kevin, thank you so much for your presentation, for your project. That's actually super cool. I'm gonna try it out to explore if it's possible for me as well. So yeah, definitely worth keeping an eye on. And I think if you come up with a simple, let's say, hello world kind of a tutorial in which you showcase Gugnir plus maybe some HTTP routing of a sort, like you plug rated to it, you make auto generation of your Swagger schemas, and the only thing you need to do is to add your models and your handler functions. Then you probably have a very compelling tool to propose to the broader community, because that would be like end-to-end, full-blown web application, which is most of what happens in Clojure land, I guess.
Okay, thanks. Awesome. Yeah, I'll take a look at that.
Yeah. All right, so that's the end of the presentation from Kevin, and it's the end of the official, let's say, agenda for the meetup today. We can decide to do a couple of things, either find something interesting, something else to talk about, or we can just close it down right here, right now. So let's make a run. Let's see, does anybody have anything interesting that can be the next subject of discussion here?
Yeah, Carlo. If you guys don't mind me going first.
Sure.
I've been looking into Clojure for about a year now, and I'm finally at the point where I can say, hey, I'm like a beginner now. I kind of have this idea of data structures, and like you want to have 10,000 functions that manipulate one data structure because that's much powerful than otherwise. But it's very hard for me to kind of scale up, if you know what I mean. Like I'm trying to parse some JSON, I'm trying to parse some XML, I'm trying to parse like a file folder into a tree structure and then kind of output it to HTML. There's all these kinds of challenges that should be relatively easy that for some reason I'm having quite a bunch of difficulty with. And in the past, I've reached out to Slack multiple times to have some great guys help me out. But it's like, what am I missing? Like, how can I ramp up to the next level and kind of figure these things out? It's very hard for me to kind of find the road to the next level, so to say.
Yeah. And what's your background in terms of languages and technologies that you're familiar with?
I've programmed a lot of Ruby on Rails, and now I'm getting into Clojure and Elixir, and I looked a little bit into Haskell and Elm because I really want to grasp the functional paradigm. But I have a more object-oriented background, although the concept of object-oriented kind of bit me in the butt quite a bunch of times, so I never really integrated it into their full capacity. I always stuck with kind of like procedural with a little bit of OO. But I've mainly come from those traditional languages that you would see in the top 20 in like Tyobe that are more object oriented. So I way back in the day, I started out with like Java, PHP, and then moved on to like Python and Ruby. And I've been professionally programming Ruby now for more than 10 years. And now I want to scale up to the next level, and it's very clear to me that that's functional.
Okay, my main area of expertise is Java. It was Java at least before getting into Clojure. Now I am doing Clojure day in, day out for a few years already, almost exclusively. If you take out DevOps and SQL stuff. I think my main roadblock was to actually grok the functional approach to things. So embracing immutability and the process of structuring your code as a sequence of transformations from the input that you have to the output that you want. Yeah. And that for me was the biggest obstacle, especially in an immutable world. So really embracing the functional paradigm in which you need to always, carry around the last result of the last execution or invocation of a function and push it forward to the next function. That was probably the hardest thing for me to learn in order to really grok the way of doing functional programming within Clojure. Okay. The tasks that you mentioned, parsing, in my book, is not the easiest of the problems to solve. Parsing JSON into a data structure is if you want, a kind of a solved problem in Clojure land. So if you want to do that, it's mostly as an exercise, I assume.
Yeah. It's more about working with the resulting data set. I mean, I can parse the XML, even though at first I had to figure out how can I parse like a 5 megabyte XML into a data structure and not sit around waiting for a minute for it to kind of pop up. And so I actually bought a couple of books, including the Clojure standard library, which is quite interesting. And some guy pointed out to look at XML sec and those types of features, same as for the file thing I was doing. I had it in the data structure, and then someone mentioned, hey, you know, look at 3 sec, and you'll be able to kind of get much further along the lines of using it. And so eventually, after quite some practice, I got to a point where I could kind of figure out how to load the data into a data structure. But then at times it was like working with it. How can I really kind of get what's going on? And recently I discovered the Clojure inspector. I don't know what the correct word is, but it's the Java pop out that kind of shows you the data elements, kind of like Rebel, although I've never worked with that. And that kind of helped me a lot too in parsing a JSON into the correct like namings that I wanted to extract. I just had to keep on plugging away like layer after layer of that JSON in order to get the actual data I was looking for using maps and filters. But I was just so surprised because I figured it would be much easier, because in the terminal I would use the JQ command to filter and select on a JSON, and I would have the answer like very fast, and I've barely ever used JQ in my entire life. Yeah. And so I was so surprised that in Clojure it's like, okay, I can finally get to the point where I have a data structure and I can kind of trust that it's the okay data structure. I know what's going on, but then it's that next level. How can I make it useful? For example, the JSON of the file folder. At first, I parsed that by using the tree command on the Unix, on the Linux command line, with an output of JSON, and then I loaded this structure into Clojure. Later on, finding out I could just run a simple Java command that would just get me the exact same thing. Although I was already glad that I could load in this data structure and have it where it's ready to go and I could work with it. But then I was like, okay, how can I turn this data structure into the output HTML I'm looking after? So I loaded up Hiccup. I started creating some of the HTML tags, and that actually worked out. But then actually navigating that tree and outputting it into HTML, I spent like at least 3 weeks on it. And after 2 weeks, I got up on Slack and I was like, guys, I really don't know how to figure this thing out. But it's the same thing. I downloaded this Wii game database from a website, which is a huge XML file. I was finally able to load up the file and have it run where it's fast by turning it into a sec. But then I was like, okay, so how do I now, because normally I would just fire up a XML client that would run that XML query language, and I would just like do a random query. It looks almost like I'm doing a simple SQL select, and I get the answer I'm looking for. Whereas in Clojure, I'm like, okay, I got this massive data structure. How in the world do I now turn it into this query that I created so easily on this other side?
What is your development environment? So how do you evaluate Clojure expressions?
VS Code with Calva.
Okay, so the way you would do it with JQ on the command line, I guess, is you just try the query and then execute it and then try again until it works, right?
Correct.
And in Clojure, I think, you can do the similar thing by just defining vars with some results and in your REPL, and then redefine them until you have something useful, and then extract small functions.
Well, I didn't save the entire stack trace of running it in Calva in the REPL, but I've spent quite a few hours running and reevaluating, even afterwards, even after like the 2 to 3 weeks of just trying to figure it out. I went back into like Ruby and I was like, where's my REPL? I got so used to evaluating things in a REPL. I was lost for the first like half an hour. So I did try a whole bunch, and I love it. You know, probably everyone does that uses Clojure, but it's very hard for me to kind of figure out how to get to that next level, how to kind of figure that part out. And I know in the Slack group, they also say, it takes time for it to kind of click. And once you get it, you kind of get it. I'm just looking for like the proven way to kind of get to that get it situation. And right now it's just like do whatever, and usually I'm lost.
Yeah, so I would agree that REPL should be your Swiss Army knife in this situation. So I don't believe that the query languages that you have for JSON and XML are easier to learn than the Clojure standard library. But usually what Michiel said is I would agree with that. You try a few things out, and usually what I would do, for instance, to navigate the data structure is to poke it with the regular filter and filter, keep, whatever you need to do, and poke with maybe parts of the big data structure that you have, getting the first X elements or getting the first item out of it, and evaluating whatever filter function I want to use to ensure that it matches, the results match what I want to get out of my query. But it's a bit hard to understand what the impedance mismatch is that makes it hard for you to leverage Clojure in these cases. It might be easier probably to try to do some pair programming of a sort, trying to do whatever you want to do, and have somebody watch over your shoulder and see and help you out with the process. That might be the quickest way forward. I'm about to melt in the temperature right now. Otherwise, I would just propose to let's just do it right now. As a matter of fact, I already created a JSON. What you said, just a 3 - j, and create a JSON out of a folder structure to try and poke a few things around. We might try it out for a couple of minutes if you want, and see if we can find, the culprit of why is it so hard for you.
And if you like JQ, by the way, there are also Clojure tools for the command line, which allow you to do pretty much the same thing, but then in Clojure, which also have an instant startup. So then you don't need a REPL per se. So you can just pipe the 3 - j output into the command. So there is Jet, which is a program I wrote to convert JSON into Eden. And it has a query language, which is similar to JQ, but it's all in Clojure.
Okay.
And there is also Babeshka, which is a full Clojure interpreter, which you can also use to parse JSON. So that might also be nice to play with.
Yeah, I've actually been seeing a lot of news last couple of months about Babashka, so that was quite interesting. I was like, hey, I met that guy. You actually got a grant from one of the Clojure communities, right?
Yeah, that's right.
Yeah, that was really cool to read about. Okay, I got pretty much everything ready to kind of show what I was working on. I did kind of get somewhere. I called it folder to HTML, and let's see if I can share what I was working on. But I must agree, yeah, I'm also turning very hot.
So let's just time box it for like 10 minutes or so and see how far can we get, and then let's try to wrap it up, okay?
Yeah, okay, sure. I'm actually curious what screen you guys are looking at, whether you see yourself right now or you see my terminal.
I see the Meetup, the call, the browser with my face.
Ah, okay. I'll turn this one into the code. Okay, so let me open this up. I was trying to do this in multiple languages, but basically I have a tree output, which here is the text file that I wanted to turn into an HTML. And finally, because I had a hard time turning this into the right structure, I turned it into this using tree again, which is the JSON file. And I also wrote like a little test so I could quickly grasp what was going on. So here are the JQ commands for me to quickly get the type of information that I was looking for, just to command some of the files together. And like I said, I could just, like Michael said, I mean, Michiel, I could also just tag along with retrying and retrying until I got it. Now let me open up the Clojure code specifically. So here's the output. Here's the run command. I'm relying on just Clojure, data.json, and Hiccup. And because of some earlier project, I've added these type of dependencies already whenever I'm ready to figure that one out. So here's the code.
Can you make it a little bit bigger, please? The text itself. Thank you.
Does this work? Let me jack in and get rid of this. And so let me turn this back into the mobility file that is the test case, so we don't end up with a lot of stuff. Evaluate.
While it is going, can you a bit clarify better what the goal is? So you want to produce HTML. What kind of HTML do you want to produce?
I actually created the exact example already that I was looking for. I kind of did a little bit of manual manipulation to make it work. Let me quickly search for that. HTML 00 program. Can you see it?
Yeah.
Okay, so every like parent should be turned into H1. And although it's quite ugly, you know, every subsection is turned into a li.
Okay.
This is just right now to keep it easy. And so if you look at that into the translation, this would be the intro, and these would be the two files associated with that.
Okay. So every directory is turned into an H1, and every file is a list item.
Yeah. And every like subdirectory, I kind of did that myself, turned into an H2. But yeah, normally they would also be a H1. Yeah.
Okay.
And so what I did was I first, you know, load in the JSON file. Let's see if I have a main here. There's my main. Ah, there it is. So I first load in the JSON file, then read the JSON file. Then I do a parse tree, turn to HTML, and then I do a print. This kind of turns into this, which is most of the way there. I just had to do some manual manipulation. However, in order to make this happen, let's see if I can kind of show you like this what's going on. So first I do the JSON file, so I slurp in this file. Then I do the read, which basically turns it into a string with a keyword based thing. And then I do a parse tree, which is what I got from someone at the Slack, and they kind of helped me to turn it into this statement, which is using treesec. And there were all kinds of things that I was trying to do myself in order to kind of get it close to that, but I never really got it. But for some reason this works. I haven't fully figured out why it works. I kind of get what treesec is doing, but its files are after directories, and I kind of wanted to have files first.
Yeah.
But I mean, I just manually updated the HTML to kind of work with that, because in the file, here's the actual file. It's way after the directory. But that was not the main problem. The main problem was actually from this JSON. Let's see if I can just call this up right now as wait, why is this not showing?
Maybe it's doing stuff. No.
Yeah, maybe it's the first time that takes a long while. I also see Calva was updated with some changes that I've not seen before.
What are you trying to do now?
So I'm trying to show you how this parse JSON looks like.
Oh, yeah. Can you maybe go into the buffer and then press Control Enter?
Ah,
yeah.
Oh, wow. I did not know that. Was that changed? Ah.
Yeah, maybe. Maybe because they don't allow you to type into the REPL anymore, so you have to evaluate from the buffer.
Oh.
Ah. I was
that is a strange choice, but I think they want you to get into the habit of evaluating from your buffer instead of going into the REPL and typing things over there or something.
Yeah. I did know in an interview, I heard the creators say something about how they're reevaluating using Calva in this type of way because VS Code is not as giving as like Emacs is.
Yeah.
Anyway, so here we got the data structure. And I was trying all kinds of stuff. First, I was like, okay, so it's a vector of 1. I would just do a first. So I would get just the inner part of it. But then later on, I figured out that, you know, if you kind of work with this recursively, all of these are vectors. So it might be better to just leave it as is. So I could just recurse it all the way down. And this was before I was told about the treesec. So I spent quite a bunch of time.
My suggestion would be that if you, like treesec is pretty hard to understand maybe. And this data structure is, like you already said, it's a recursive data structure. So why not just write a recursive function to process it? So this looks like a vector, and then you use map with some function that you are going to write.
Yeah.
And this function looks at every element, and the element is of a certain type. So
yeah, I actually kind of wrote down a little bit about this data structure here, how I was trying to do my beginner level parsing and reducing.
Yeah.
And so I wanted to add in conditional, whether it was a directory or a file, as you can see here.
Yeah, you can do that, yeah.
Yeah, but I kind of got stuck on this for so long that I eventually was like, okay, so how do I figure this thing out?
Yeah, I think this approach is easier to understand than starting with treesec, maybe.
Yeah.
Yeah. On my own, I would have never figured out treesec to kind of look at this because I didn't know that existed at all. But at first, I was even trying to figure out how in the world do I just parse this. So I tried to think about how would I do this in Ruby, and I would probably go like deeper and deeper and deeper into it using kind of like for each type of structures. And so in Clojure, I figured, hey, I could just work with the keywords, and then basically it's just keywords with vex and maps all the way down. But for some reason, I got stuck so many times that eventually I got a little bit of it working, but never the entire thing, like in this little statement that just gives me 95% of what I was looking for.
Yeah. So I think what you can try is maybe write map, just write down map, because that's what you want to do over the vector.
Mm-hmm.
And then with the function process thing or something. And then over the output, like maybe you can, oh yeah, JSON parse, yeah. So now we are going to write the function process thing, right? And yeah, so the thing, so it has an argument thing. And if the thing, if it's a file, we're basically done, because the file doesn't have any children, right?
Correct.
So
although it could be part of a vector, but yeah, basically the file is the latest. Yeah,
it's the latest, it's the leaf. So if so, you check if the type is file.
Let's see, it's been a while since I've been in here. So is it something like I did here?
Yeah, you can do that as well. But I think we can do just with an if, because there are only two cases that we need to handle.
So I'm a little bit out of shape on my if in Clojure at the moment.
Okay, so it's just if and then the condition. So the condition is equals, I think, because we want to check if it's file. Yeah. So if
thing.
It's file. Yeah.
File.
Okay. So what do we want to do in this case?
So if it's a file, and I've created some helper functions right here. So file to HTML, we want to turn the file name into Lee. Okay.
So we have to call file to HTML with the file name of this thing, right?
Yeah.
Okay. So now file name. Yeah. Okay. So then we're done. And now we will handle, if it's not a file, it must be a directory, right? So, yeah. So now we can handle the directory. So how are we going to process this thing?
So at first I wrote this little thing where I just turned it into an HTML.
Okay.
But what I ended up doing here, I think it's in one of these cases, is where I first turn the header into an HTML and then kind of parse the folder along the way. Here. Although I would first do a do print line to output, and then I would kind of process the contents, which is the keyword that is in the directory. Okay, but first let's turn this into data and not try to print anything, because printing is a side effect. Yeah. So we try to avoid it. Like we do the printing only as the last step. Yeah. So let's process the directory. So maybe we can just write a function process directory. Okay. And give the directory to that function. So thing. The thing, yeah. Okay. So now we so we will define a process directory. Okay. So maybe you want to turn this into some HTML, or I don't know. So yeah. So maybe you can write like li. I could like first kick it off into the directory to HTML. Like that. Yeah, but we can only return one thing, right?
So we also have to do something with the contents.
Yeah, exactly.
So what we do with the contents, that's another vector. So we want to we want to do the same with that vector as we did in the beginning, where we said map process thing JSON parsed, right? So maybe we can also define a function for that.
Okay.
So we call it process vector or something, process file list, or I don't know what. Files, maybe just files.
Files, sure.
Yeah. And now you can call the argument files, maybe. Yeah. And now you put the map process thing into, right. Files. Okay.
Okay.
So what you want to do in process directory is you want to do something with the name, but you also want to give the contents again to process files, because, right?
Something like
something like this, yeah. So maybe the contents, yeah. So, and maybe instead of do, maybe you can use a vector or something, because do will only return the last thing.
Okay.
So maybe
that explains why I lost some of my HTMLs in the past.
Yeah.
Okay.
So maybe just return a vector of both these things.
So I would turn it into this.
Yeah. Okay, and the only problem we have left, I think, is that process files isn't yet defined, so you can use declare for that.
Declare. Yeah, I was looking for that.
Process files. And maybe if we now run process files over the JSON parsed, maybe it will do something useful. I don't know, but we'll have to evaluate all these things.
Yeah, but I kind of see where you're going. At one of the times I got stuck was actually this very case, where I was like, okay, so how do I go now from getting the name of this directory like I do here with this function, and then actually continue on the parsing of the content? And I was looking at things like reduce, I was looking at like loops and recur and all these things. I just, for some reason, couldn't figure out. But turning this into a vector that would return, kind of changes a lot already, because these are just two data structures that you can then work with again in the future.
Yeah, right. Yeah, maybe we can try this out and then see what it does.
It did compile, I guess.
Okay, and now process files on JSON parsed, I guess. Okay.
Here's
oh, good. That's interesting.
that's looking very promising, actually.
Okay.
So this is basically the easier tree structure than before.
Yeah, there's some nesting to be figured out, possibly like lists and stuff like that. But yeah, it's fairly far away.
All right.
So I think the lesson is like, don't use side effects, but first build up like the data, and then process the data with maybe print line or whatever, write to a file.
So
but,
don't do side effects. I'm actually learning that from Eric Norman's book called Grokking Simplicity, on how to put side effects to the edge cases.
Right. Yeah.
Trying to incorporate that. So don't do side effects. First turn into usable data structure. Then finally print/do whatever you want with it. Yeah. Okay. this already helps a lot. It also shows me that you don't necessarily always need to turn it into like some type of recurring or looping structure, or reducing the whole thing. That was kind of where I ended up looking at, because I figured, hey, I'm doing everything wrong. I probably need to look into that direction, because you're continuously calling this thing up to until itself. But this is working quite nice.
Cool.
And so I kind of had the same thing, and I'm sorry for taking up the time longer than 10 minutes here. I'll just quickly show the other thing I was trying to figure out. No need to kind of dive into that. But so here I'm kind of loading in this XML, and I'm trying to figure out how to read it and parse it, and then here, finally, I figured out, hey, I can just sec it so it becomes a lazy evaluation or a lazy sequence. And then I was trying to filter it. And here's where I kind of got a little bit stuck figuring out how to proceed. Whereas the X query was just really simple, you know, search for statement, do this type of query, and call it a day.
I think this is exactly the same problem with your directory structure, because this XML is a nested thing, right? So you have to walk over each thing. So it's basically the same problem.
Yeah. So you're saying I should just look into map much more often to kind of do these types of things, and then kind of build up like a data structure that holds these types of things?
Yeah, just write small functions that you can understand individually, and try them out also with data in the REPL. And but the key part here is recursion, I think. So that is the hardest part here. To like in a side affecting language or a mutable OO language, you would probably do this with mutation, like, oh yeah, we are now at the directory, so I spit out the name to a file or something. Yeah. And then I process all the children, which are also right in a loop. And I think that kind of thinking gets in the way here.
Yeah, I'm actually I created a little project that I called a playground, and here I'm trying to figure out all of these recursion type of things and keep on going until it kind of clicks, so I don't have to second guess myself, because this is really one of the hard parts for me, is like, what is recursion and how do I kind of make it work? So I'm trying out all of these different types of combinations to see if I can make it happen.
Yeah, that's useful. And maybe you can also have you looked at the for Clojure website? They have a lot of exercise.
Yeah, I looked at Exorcism for Clojure, and there's two other websites, the Clojure cones and the Clojure script cones.
Yeah.
I'm kind of working through those very, very slowly, as usually I get into trouble somewhere and then I kind of have some other interesting project I want to figure out and get stuck again.
Yeah.
So yeah, that's why unfortunately it's taken me a long time. It really excites me that once you kind of get this, there's so much power you have at your fingertips. Yeah. All right. Thank you guys for helping me out. I will definitely be looking more into this and adding some comments to kind of work on this some more. And hopefully this will eventually get me into that next level, especially the tip about turn it into a data structure first, then try to parse it using some kind of function. I really like in functional programming how you just put a function around everything and you can reuse it and do everything you want with it again and again. It never gets tired. The modular approach, I would almost say.
If you ever branch off into the other more, let's call them strict functional languages like Haskell, you'll find out that they don't tend to do it that way. They tend to do everything with types instead of functions.
Yeah, I heard something about using types and then monoids and all these other
Yeah,
category theory data structures. Yeah,
it's a very different fish. Call it that way.
Yeah. At first, I wanted to branch off into, well, I kind of started with Elixir because it looked like Ruby, but it's a very dangerous approach because it's so easy to fall back into the patterns and habits of Ruby. So then I tried out Haskell and I was like, wow, this is so difficult. I got a couple of books, started working through them, and eventually some little pieces clicked, but it never really got it. And then with Clojure, I kind of got over the first hurdle. I'm just stuck at like these type of things. Like, how do I get it to that next level? How do I get to the real beginner level where I can actually do things with these type of more difficult data structures than just basic vectors, maps, and all these things? It's going to take some time, but these type of helps and peer programming things really help.
Good. Glad to hear that we were of service. And before I forget, on the comment of strict or type-based functional languages, I'm sharing a link of a fairly amazing blog post from a fairly famous Clojurian, I guess, the inventor of the Jepsen distributed systems testing tool. I've thoroughly recommend that blog post. Is about solving the n-queens problem by encoding the solution in the type system of Haskell, without writing any function at all. So
these guys also had a Clojure tutorial, if I remember correctly.
Possibly, yeah.
Yeah, Clojure from the ground up, it's called.
Yeah, that one, yeah.
Around 2013 or so, it's already quite old, but still relevant because Clojure doesn't change that much.
Yeah, that's another part I really like, the Rich Hickey effect.
Yeah. All right. On these notes, we went, almost to the half an hour with the second, let's say, event of the evening. I would like to close it down for now. I would say big thank you guys for joining the meeting tonight. It's always nice to participate in such events where you just ask around if somebody has anything interesting to say, and there you have it. You have half an hour at least of an interesting discussion. So it's amazing to be with you guys. Thank you for coming again, and looking forward to see you again next month, because hey, Meetup 128 is not going to be the last one. So yeah, not going anywhere.
All right.
Thanks a lot for organizing, Carlo, and
Thanks.
don't melt away, and hopefully
likewise.
next time.
Yeah, thanks a lot. It was a lot of fun.
Take care, everybody. Bye.
Thank you. Bye bye.